I think we left off at creating a client from a GraphQL client for consuming the API which we exposed from our API server. So this was our API server, and here we have a simple type def with one entity, post, and a query to fetch a list of those posts, and we have a JavaScript resolver for that particular query. This is the posts query. It simply returns a static list of objects. My goal in this video is to integrate this API server with our client. And the next video I'll try to type save all of this. So here, like posts, what does posts mean? There's no type annotation to posts. It's just a list of objects. So it can have more items here, but at least it should have this. Like if you don't put title here, probably you'll be getting some sort of an error because title is required, but that's a runtime error. There's no way you can find that out during compilation. So we'll try to make this type safe so that we can discover these errors during compile time, because that's the whole point of using TypeScript. But for now, we'll just try to integrate the API server with our client application. So the API server should be running at port 4000. Let me just fire that up. So for terminal, I'm using Terminator. It's an Ubuntu machine. And Terminator, interesting thing you have is layouts. So I have a preset up layout. Pretty handy if you want to start up, if you don't want to go through the hassle of setting up your terminal layout every time you start up your machine. So I'll just move to our working directory. One issue with Terminator is it's a bit buggy every now and then. For example, I couldn't set up the working directory during in the layout settings. I guess there is a place for setting it up, but I just couldn't work it out. Like this particular field doesn't work. Like whatever value I input here, after saving, it just goes away. At any rate, we digress. So let me just fire up the server first. And take a peek at the logs. Like I mentioned in the previous video, like these commands, start, logs, these are basically shell scripts I wrote myself to leverage Docker Compose. So basically start, what it does is it just runs Docker Compose up, and logs, basically what it does is it runs Docker Compose logs. So as we can see, our machine is up, our container is up. Let me shell into that container. This too is a bash script I wrote to use Docker Compose to shell into the container. So we have a script in package.json to run the server in dev mode. So it basically runs Webpack in watch mode with the dev environment. So this is what our webpack.config basically looks like. We covered it a bit in the previous video, so I won't be going deep into it. I'll share the link to my source code in the description. Yes, you can just go to Roses on Fire. So this is the URL. Yep. So I haven't pushed the latest changes here, so as you can see there are lots of changes. I will definitely not recommend to work like this for in a team setting, or even in an individual setting if you're working for a corporation or a company. I mean, this is just because it's my pet project. I'm just getting it started and playing around with it, that I have this tons of changes staged over here. But I would highly recommend to follow proper Git practices, especially like creating your commits small, creating your PR small, easier to review, easier to address feedbacks, and it's just less hassle. And at the end of the day, you have more PRs. Like if that's something your company watches out for, right? I mean, it's a total fallacy, but some companies do look into the number of PRs you make per day or per week. So if you chunkify your PRs, instead of giving 1,000 lines of code in one PR, if you can break that up into like 10 different PRs, that might be a booster for you, for the company. I mean, if that's something your company looks for. Also, like, it's easier to review, it's easier to keep track of, easier to address feedback. Like, I for one do get a bit annoyed if I see several PRs waiting to be reviewed in my GitHub, each of them like more than 500 lines of code. Like, if it goes above 100 or 150 lines of code, that really bothers me. And I believe a good PR should be limited to less than 100 if possible. If you need to create multiple, if you need to create a lot of changes in one PR, I would suggest at least break that up into semantic or organized commits, instead of like making all those changes in one particular commit. And then if you can break that up into multiple commits, then it becomes easier to strategize how you can break that PR up into multiple PRs, since your commits are now already segmented. Alright, so let's get back to what we were doing. So I think our server should be up by now. Okay, so again I forgot to run the server actually. So I just need to run yarn dev to start it up. So Webpack is running in watch mode, and like we mentioned previously, we do have NodeMon set up as a plugin for Webpack. So it's the NodemonPlugin for Webpack. So this particular package, NodeMon Webpack plugin, pretty handy. You don't have to set up your own NodeMon configuration separately. You don't need to run NodeMon in a watch mode and Webpack in a watch mode in two different scripts, run those in parallel. You don't have to go through all that hassle. You can just set it up, the NodeMon plugin, and Webpack will take care of it for you. You just need to show the path to the script that needs to be run and the directory that needs to be watched by NodeMon, and the delay. Instead of NodeMon having continuously to watch the folder, it will have sort of a debounce time, right, of 1 second, reasonable enough to not overclock your CPU or not take up too much of your resource. Okay, our server is up at localhost 4000 GraphQL. Let us just navigate to that, and as we can see, our schema is right about here. There is our entity post, and there's a query for getting a list of posts. And if we run this, we'll get our static data. returned. Let's just call it a schema. We have a schema here, and we have a query definition language, I guess. What is this? Scalar upload. I have no clue what that is. How the scalar upload works. Okay, so there you go. Note when using type devs, Apollo server adds scalar upload to your schema. Okay, but what is that? So any existing declaration of scalar upload, the type definition, will be removed. Okay. If you create your schema with makes executable schema, pass it to Apollo server constructor using schema param, make sure to use scalar upload. What is scalar upload though? So it's a way to upload files, I suppose. Okay. Oh, okay. So this is like, okay. So I think this is similar to what we once did in one of our projects. So imagine this: you have a REST API, right? And you have API for getting stuff, for posting stuff, for patching data. But now you want to have a way to post blob data, maybe file data. How do you upload that file through the REST API? Well, obviously, like, you can just send in through the multi-part upload or form upload stuff. But imagine those are not, like, those don't feel restful, right? That's one problem. And the second problem is the upload of files. There are lots of different parameters that needs to be considered, which we don't need to consider usually for REST APIs. For instance, chunkification, right? Your REST API, like at least the one we built, was reasonably sized in terms of pagination. Like, you cannot have more than a certain number of objects in a particular response, and you cannot send more than a certain number of objects in request. So that way we somehow limited the size of each request and each response. But imagine this: you have a file to upload, and that file doesn't have a small limit. It can go as high as gigs, 3 gigs, 5 gigs. Now imagine servers around the world posting files through your REST API. I mean, that kind of scale, that is best left for PaaS guys like AWS, Google Cloud, Azure. These guys handle this well. So instead of us managing those uploads, managing those chunkifications, those upload accelerations, speed of upload, reliability checks, all of those stuff, instead of us doing that, and also security, rate limiting and whatnot for our files. I mean, the rate limiting for our REST API was handled by us. For the file upload, like, instead of us going through all those hassles, like creating a bottleneck, our server being a bottleneck for the file to go through from the client side all the way up to the whatever storage we used. That instead of going through that path, we decided, okay, let the experts who have invested millions of dollars and billions of dollars into that sector handle it. So for uploading files, we chose to have a separate route than our REST server. So you upload the file through that route, which is basically handled by the whatever third parties service provider, AWS, Google Cloud, whatever it is. And once the file is uploaded, you make a post request basically through our REST API and tell us that, okay, this is the file that I need to be added as a resource, and you send in a reference of that particular file which you uploaded through the third party. I think this is similar to that. So let's just go and read, because it says file upload with the Apollo server and it doesn't have a schema, right? It's not GraphQL, it's just a separate endpoint for uploading files, I think. So it says, okay, so you have file here, file name, and query uploads file. Okay, so let's just see. It's a scalar, right? What is a scalar? Now the question is GraphQL scalar. What is a GraphQL scalar? GraphQL object type has a name and a field, but at some point those fields have to resolve to some concrete data. That's where scalar type comes in, represent leaves of query. Okay, so yeah, so I think scalar means the same thing that it means in other programming languages, right? Like scalar are the lowest unit of data abstraction that exists out of the box from a language, and then you have vectors, that is maybe a collection of those scalars. Or like sets and stuff. So basically scalars is the lowest common denominators of data representation. So I can have a scalar which is integer, float, string, boolean. So what is this scalar upload? I don't know. How do you declare a scalar? So you have scalar date. In most GraphQL service implementation, there is also a way to specify custom scalar types. Okay, for example, we could define a date type. Then it's up to our implementation to define how the type should be serialized, deserialized, and validated. For example, you could specify that the date type should be always be serialized into an integer time. So okay, so do you have an example of anything like that? I don't see an example. So let's just do a YouTube search, right? GraphQL scalar. Plenty of good people out there building examples just for us. Let's just leverage that. So we have our server running. Let's look at the changes. This is the changes in the client side. So let's open the client. So the first things first, let's define our types, right? So we have our types defined right about here. Let's bring those in. So instead of these, let's just rewrite here. So we have our types here, and then we need our clients. This is our Apollo client. That's cool. And then we need to create a fetcher for our SWR. So just call it GraphQL. So the fetcher is like GraphQL fetcher. Then you have a query, which basically makes a query to a client. So where is our client? This is our client.query. There we go, client.query. Let's not try to make this type safe right away. Let's just keep this in. So you have our GraphQL client, and you have our GraphQL fetcher. Can we come and do that? So you have right, HTTP API, and we just need a GraphQL API similar to this. So So for this case, you don't need the URL, you just need the query. The query is definitely a string. I wonder what's the difference between this and that. Same in Java, right? I don't need that right now. Let's not get too fancy right now. We can type safe later. Let's try this. That's about it, I guess. So far, what we have done is we have created a type def for our GraphQL. So this is our API utility for HTTP, and this is the one for GraphQL. So these are the type defs that we have. This is the GraphQL client. So notice that the caching strategy is in memory cache for now. And the type defs are provided here. The type defs are same as the type defs in the server. So the GraphQL fetcher takes in a query. passes it through to the GraphQL client. That fetcher is used for our use SWR. So let us see posts. So so we have /API/posts. Which basically makes the request here, and then from here we reply. So this is to be done by GraphQL. So this is the API controller for NextJS. In NextJS you can put all your APIs into a particular folder under pages called the API folder, and then inside that you can export your controller. So they call it an API handler. So basically it's a function that takes in a request and a response, similar to that you do for most other web servers like Express. So previously we used to send back a static response. Now let us make an SWR query here to our GraphQL server instead of returning a static response. So where's the query like? The query is like this. Let's just pass in a string for now. Let's see what it returns. So my debugger is on, I suppose. Okay, I have not started the server, I guess. Okay. I just started the client server. Now, one thing I need to show here is that so we run our containers using a script. This is the script for the client container, and here you will find that we run yarn in development mode. We run yarn dev basically. So yarn dev, what it does is sets a node option for inspection. This is useful for debugging, which I will show you shortly. So still installing the dependencies. Okay, it's running, and let's go to localhost 3000. Oops, something is wrong here. Okay, let's start the server. Let's start our server here. Build. Now this is good. So because I haven't done that. Okay, let's restart the API server again. Okay, Webpack is running. Let's start the log. Yep, the server is running. So if I go to the server, yes, it's working. Now if I go to client side, what happens is I expect the debugger to be triggered. So I just need to run the debugger here. So launch program. So the debugger is running. I just need to go to the client side code. It's loading. There we go. Okay, so there's clearly some errors here. So first error is localhost API posts. This didn't work. The reason this didn't work is, if you read the log here, invalid hook call. Hooks can only be called inside the body of a function component. So it's not a hook. SWR. So we are calling SWR, right? So we are calling SWR from our utils, right? Sorry, not from our utils. We are calling SWR from our API, right about here. The problem is that this is an API. It is not a component. So if I go to SWR, run outside component, can I do that? It's a React hook library for fetching data. I suppose you can't do that. So let's just use GraphQL Client here. This particular util, instead of calling it API, we can call it GraphQL. Okay. Let's see what happens now. Let me just refresh the page just to make sure that the data is not somehow getting served from the cache. So you see there's still errors here. What's there? You must wrap the query string in a GQL tag. And what is GQL? Oh, let's see if it works. Okay, it worked. So what's the response? The response is a promise. So it's a promise, right? So you can just do async and then you can do await here. Cool. So you have the data here, and there you go, you have the posts. So you can have data, and that is your posts. Okay, so we can just return that. Let's see. This is showing the data from the API server. What I'm trying to do now is I changed. Okay, so this data got changed. Okay. So if I go and here put a 1, this is the API server, and put a 2, and if I go to my GraphQL server, I see 1 and 2 right away. However, if I do this, I don't see 1 and 2. It got cached somehow. Now, who is caching it? Is the browser or is it the server? So this is definitely not the browser, because it's sending this request and getting back this response. I was trying to find out if there's a way to change the timeout in memory cache. Couldn't find anything like that. Cool, no worries. It's working. That's the main important thing. So what were we doing? We were trying to start our client in production mode. This. So we don't need to do anything really, we can just shell into it and run start. The build process has started. So you can see which rendering each of these pages are experiencing. So like this one is like lambda, that means it's server side rendering, serverless basically, and these are static, client side, both of these are static. And then this you can ignore. These two ISR, okay, these two are server side rendering, these two are SSG, and these two are static. Cool. Now if I go to localhost 5000, let's see, let's go to network, refresh the page. It should be loading all of those preemptively. Okay. So for example, right, SSG with state without scalar. But if you see the network here, these will not be loaded preemptively. See? Since this is in production, it's optimized to do that. Now each of these files, each of these pages will take some time to load. See? Take some time to load. All of these files will take some time to load. But after the first loading, it will not take much time. Okay? Because it's been loaded. But when you are building in production, you'll see that it loads immediately. That is because in production the links, hyperlinks are preemptively fetched, like I showed here. As for the props and data that needs to come from somewhere else, that is different. So if I go back to home, if I show you this one, so see, it took some time for this to get rendered, but the point is the initial page got rendered very fast, right? So if I go back to this, you see the data is already there, and it's not going through any revalidation.